Welcome fellow learners. In this video, we will learn how to use dynamic few-shot prompting with Llama 3, an open source LLM on a local system. We will create a custom SQL agent to implement React logic for dynamic few-shot prompting, and we will use Ollama to import quantized Llama 3. So let's first write down what are the different steps that we are going to follow in this notebook to implement this dynamic few-shot prompting using Llama 3. In the first step, we are going to import our LLM, this Llama 3 model. We will utilize Ollama to import this Llama 3. Ollama is an application that helps or facilitates us to use open source models like Llama 3, Gamma 2, Mixtral. This Ollama provides quantized versions of these models like 2-bit quantized, 4-bit quantized, 8-bit quantized, such that we can use these large language models in less compute resources also. In the second step, we are going to fetch the data, and we will use Chinook database. This consists of multiple tables in a single database. Next, in the third step, we will initialize some few-shot examples. Once we have these few-shot examples, we will convert those few-shot examples to embeddings. To convert these few-shot examples to embeddings, we will utilize this Llama 3 model. And once we have converted those examples to embeddings, we will create a few custom tools. These custom tools will be mostly related to SQL database, as we are going to create a SQL agent. And in the next step, we are going to create a prompt. We will use these tool names and their corresponding tools description to create a suitable prompt. Once we have created this prompt, we will create an agent with React logic. With the help of this React logic, we will make sure this agent first reason it out as per the user's query and then accordingly take actions. And finally, in the 8th step, we are going to create our agent executor, and we will use this agent executor to test out this agent's functionality. So these are the 8 steps that we are going to follow in this notebook to implement this dynamic few-shot prompting with this Llama 3. So let's directly jump into the code part. So in the first step, we will import this Llama 3 model. We will be utilizing this Ollama to import this Llama 3 model in quantized format. Langchain already provides this Ollama module, so we will be using that directly over here. And if you can see, this is pretty simple to import this Llama 3 model using this Ollama. You can just pass model equals to Llama 3, and it will basically import that Llama 3 model in this particular notebook. We can also test it out. We can just invoke this model and pass any simple queries, like I will just pass hi, and it will provide us the result. It will take a few seconds as it is running in this local PC. And if you don't know about how to install this Ollama in your local system, I have created a separate video. I will paste that video's link in the description. You can follow that video and watch that video to how to install and basically implement Ollama and the corresponding large language model in your local PC. So now you can see it's implemented in this notebook, and we have imported that Llama 3 model in this notebook. And it has provided result like, hi, it's nice to meet you. Is there something I can help you with? So now we have imported this Llama 3 model in this particular notebook. So in the next step, let's fetch the data. We will be utilizing this Chinook database. It consists of multiple tables in a single database. So let's run this cell. We can also print more information about each of these tables and this database. We can use this db.table info to fetch those information about each of these tables. So you can see this print out table schema and their corresponding 3 rows from each of these table. So like you can see this track table, then you can see this playlist track table, and similarly playlist table, media type table. So these are the tables that this database consists of. This consists of around 11 tables in total. So now we are having this database with us. We are also imported this Llama 3 model LLM. Next, create some few-shot examples. So like I have already written down these few-shot examples. So like list all tracks in the rock genre. So it should create a query like select star from track where genre ID is. It has also created a query within a query. So these type of few-shot examples I have already created, and we will use these few-shot examples in dynamic nature to feed it to prompt as per the user's query. So let's run this cell, and now we will be having this list of these few-shot examples. So in the next step, we will be converting these few-shot examples into embeddings. The reason why we are converting these examples into embeddings is we are going to apply a RAG-based approach. As we are going to implement a dynamic few-shot prompting, we will be dynamically at the runtime, whenever a user passes a query, we will use that query and then convert that query into embeddings and do a similarity search, and we will find out top k few-shot examples from these bunch of examples, and we will append those top k examples into our prompt such that LLM would already be having an understanding of how these users query can be converted into SQL queries. So for that part, converting these few-shot examples into embedding, we will be utilizing this Llama 3, and this Langchain already provides a module, Ollama embedding, which we can utilize to basically import this embedding module. So let's run this cell also. You can pass model equals to Llama 3 directly into this Ollama embeddings module. Then we will be using two major modules. One is FAS, another is a semantic similarity example selector. The FAS module is basically Facebook AI similarity search. This module will help us to do similarity search, and this semantic similarity example selector is a module which basically simply select top k examples with the help of this FAS. So you can say it's kind of a wrapper above this FAS module. So we just need to pass those examples, those few short examples, and this embedding module, this particular Llama 3 embedding module, the kind of similarity search, this FAS, and the number of top k examples that we want to fetch for each time we passes a query to it, and then some simple input keys. Here we are basically classifying the input keys as input. So let's run this cell. It will take a while, as it will first convert those few short examples into embedding and save those as vectors. Once we have done that, we will be having this, all these 10 few short examples will be converted to embedding vectors. Now we can run any query to this example selector, and it will fetch us top 3 few short examples from those bunch of few short examples. So we can do that in this way, like we can use this example selector, and we can call this search function. We can pass our query and kind of similarity search that we want to do. We can either pass that cosine similarity. For that part, we can simply write over here similarity, or we can use this MMR, maximum marginal retriever. These are the algorithms that we can use for the similarity search. So once this process is being done, we can run this cell, and we can find out what kind of queries from those bunch of few short examples matches with this particular query. So let's run this cell. So now you can see this has given us the result. We can also print out it in a better way, like we can run a loop on this for doc in matched queries, and then we can just print out this doc.page content. It will be better to see it in this way, like with according to this query, how many artists are there. This particular embedding model has given these 3 queries, like how many tracks are there in the album with the ID 5, list all artists, and how many employees are there. So like it depends on the kind of embedding model that we are using. Currently we are using Llama 3 model, so that model is not specifically trained for fetching out the embeddings. You can use any other models like Mini-LM V2, Distilbert, which are basically specifically trained for embeddings, and those kind of models will give us better results. So that's okay for this particular use case, and for this particular notebook we are okay to go. So now in the next step, we are going to create few custom tools. As we are using our database, SQL database, we will be creating few tools which are mostly related to the database. We are going to create an agent and basically bind that agent with these tools. So I have used these 4 tools. I will just explain these tools. So like the first, let's run this cell first and let's see what kind of tools are these. So like if you see the first tool, this SQL DB query, it is basically will be used to run a query on the SQL database. So like when user passes a query to LLM, it will create a query, and then on the basis of this SQL DB query tool, it will execute a SQL query against the database. The second one is SQL DB schema. It will fetch the schema for the different tables from the database. Third one is SQL DB list table. It will list down all the tables from the database. And the fourth and final one is SQL DB query checker. This will use LLM to check out if the query generated by our LLM is correct or not. If it is not correct, it will again run the loop and try to create a new query. So these are the tools that we are going to use in our particular agent, which we are going to create next. One more thing you might notice, I haven't created any particular function to import these custom tools. Instead, I have used already predefined tools available in the Langchain, like Query SQL Database Tool, Info SQL Database Tool, List SQL Database Tool, and Query SQL Checker Tool. And then I have passed these database that I have imported earlier and the LLM which I have imported earlier to make these tools as custom tools. So you can see that these three tools only requires database, and this final Query SQL Checker tool also requires this LLM. The reason is it will use LLM to check if the query generated by the LLM is correct or not. So now we are having these tools in this notebook. So in the next step, we are going to utilize these tools and create our prompt. So for the creation of the prompt, we need to create a dynamic few-shot prompt template. For that part, we are going to create two prefix and suffix. One is system prefix and another one is suffix. So if you see, after this system prefix, I will append the dynamically selected few-shot examples from the bunch of examples that we have seen earlier, We will use those examples and we will append those top k examples after the system prefix, and after those examples, I will append this suffix. So this way, we will create a complete prompt. So you can see the kind of prompt which I have created. This is prompt is used for the React logic, where we want our LLM to first reason it out and then act or take actions accordingly. So I have provided this format to it. So like the user's question will be there. Then LLM you should always think about what to do. Then you can take any action according to the tools that has been provided to you, and then take those actions, any particular one action, and then observe the result of those action, and then you can repeat these steps n times. If you are not able to find answer in a single step, you can use the next step. If you have seen the query generated by the LLM is incorrect, you can again generate another query. So you can run these steps n time, and then finally, if you think you know the final answer, you can basically exit this loop and provide us the final result. So this is kind of the React logic that I have provided to this LLM. So let's run this cell, and let's run this second suffix also. In the suffix part, you can see it's simple. I have provided a user's question and then corresponding agent scratchpad. At the start, this agent scratchpad will be null. So like if you think about it, this agent scratchpad is kind of a notebook that agent uses to see what are the different tools and what are the different actions that it has taken in the previous steps. So now we have created these prefix and suffix, and with the help of these prefix and suffix, let's create prompt templates. So we need to first create a dynamic few-shot prompt template. So for that part, let's first import this few-shot prompt template and some other modules. So let's run this cell. And if you see here in this few-shot prompt template object, we have passed different parameters to it. The first one is example selector. This example selector will select few-shot examples dynamically. And then this is the example prompt. This is the example prompt to help this example selector to return those few-shot examples. As we can see, our these few-shot examples are in this way. Like first there will be user's query, and then following there will be SQL query generated. So this is the corresponding example prompt that we are also going to pass to this few-shot prompt template. Next, this is the input variable that I have already talked about. We are going to pass it as input key, and then we are going to pass these two prefix and suffix. Now what this few-shot prompt template will do, it will fetch those top k few-shot examples and append those top k few-shot examples after this system prefix, and after those few-shot examples it will append this suffix. So let's run this cell, and then we need to create a complete prompt which we are going to pass to our agent. So for that part we can utilize this chat prompt template, and in this system message prompt template we can pass this dynamic few-shot prompt template that we have already created. So let's run this cell, and now we have created this complete prompt that we are going to pass to the agent. So let's take an example and let's see which particular prompt or what kind of prompt does this will generate for us. So I'm just passing this how many artists are there, and the tool names for it, all the tool names for tools that we have created and their description to it. At the start this agent's dashboard will be null. So this is for just for an example purpose. We need not to pass these tool name and description to our agent, as agent will take care of it by itself. We just need to pass these names and description over here to see how this complete prompt will look like. So you can see it has generated this prompt. So this is our prefix. Answer the following questions as best as you can. Then it has appended this tools, all the tools you can see. If you see in this prefix, first we need to append these tools, and then these are the basically React logic, and here you can see it has appended this we need to append this tool names. So accordingly you can see in the output, first it has given this description for all those tools, and then over here you can see it has appended the name of all those tools, and after this you can see it has appended these top you can see top k few-shot examples from our example selector, and after that it has appended that suffix to it. So in this way it will create this complete prompt that we are going to pass to our agent. So now we have our LLM, we have our database, and we have our prompt. So, and also we have also created those few-shot examples and also few-shot example selector. So now in the final step, let's create our agent. To create an agent with React logic, we can import this create React agent from Langchain, and then we can pass these LLMs and tools and prompt to it. So let's run this cell, and if you see a description of this create React agent, it requires LLM, tools, prompt, output parser, tools renderer, and other parameters also. So we only need to pass these three to start with. So like you can pass also output parser if you having different kind of output from any LLM. You can also tools renderer, where it will be having a description of each of the tool, as the tools that I have used is already having the description of those tools in their definition. Like you can print those tools dot description, and those description will be there. So we need not to render those description and pass over to this React agent. So now we will be having this agent. Next, we can create an agent executor which will take this agent, and with the help of this agent executor we can test any query to it. So we need to pass this agent, we need to pass this tool. We will be using this verbose equals to true to see intermediate steps followed by this agent executor. We will be passing this handle parsing error equals to true to make sure, like sometimes these models quantized open source model like Llama 3 to 4-bit, they might not be able to provide results correctly. So there might be some results which can create error while parsing output in these agents. So for that part, I have just passed this handle parsing error equals to true. So let's run this cell also. Now we have this our agent executor. So let's run a query. So I have just passed a simple query like provide the number of customers with respect to each country. So let's run this cell. This agent executor will take few minutes, because we are using this Llama 3 in local PC, and I am having only this particular 16 GB of RAM, and while only 4 GB of GPU. So that's why it will take little while to provide us the result. Now you can see it has given us the result, and we can also see what are the different intermediate steps that this particular agent has followed. So like in the first step, it find out it needs to run this SQLDB query, and then it run that query, and it has generated this query and then run that query. But in the second step, it again find out it needs to run that query, which is the unnecessary step. But this is the problem with the quantized versions of modules, quantized versions of these models like Llama 3 and all. We need to either fine tune these models, or we need to use full precision or higher precision models. But you can see in the final step, it find out like it needs to exit the loop and then provide us the answer. So it provided us the answer like the number of customers with respect to each countries are these. So you can see Belgium 1, Brazil 5, and Canada 8. One more thing that you can use is you can import Langchain and then do langchain.debug equals to true. And you can see further intermediate steps that this particular agent has followed. Like you can see each of the chain, each of the runnable sequence that it has followed and gone through. So you can see these are the steps that this particular agent has followed. So like if you see the first prompt that it has created is this. You can see this is the prefix I think that we have passed to it. And then you can see here over here it has created few it has basically selected those few short examples. Like here are some examples of the user input and their corresponding SQL queries. So like list all customers from Canada. You can see here like find the total number of albums, and then it has basically added this suffix. So this was the first prompt that it has created, and after this you can see this has generated this result. And then after this you can see the next step that it has followed. It has then find out it needs to run this SQLDB query, and it has created this query. This will be the input to this action, this SQLDB query, and it will basically execute this query in that particular database. And then you can see it has executed that, and it has given this response to it. And then it find out this, and then finally created a new prompt. You can see over here like it has created this new prompt. So it has first added this query, provide the number of customers with respect to each country, and then it has also added what was the action that it has taken, like SQLDB query, and then output from running that particular query into the database. This is the output from that database. So in this way this particular agent work, and you can see results or in the intermediate results whenever you do this langchain.debug equals to true. So great, we have seen that how we can implement this dynamic few-shot prompting with this Llama 3. You can utilize any other open source models that are available in Ollama, like Gamma 2, Mixtral, Quen 2, or any Phi 3 model. Those kind of models you can utilize, and then you can test it out in your local system. And you can also test out with different datasets. I have used a simple Chinook dataset, which is consist of having multiple tables in the database. We can also test out with other database, your own database, and check it out and see how does this perform with your data and different LLMs, other LLMs that are available in Ollama. So great. Thanks for making till the end of this video. Goodbye until the next time.